Alright, this is chapter 8-2. Please copy your cards. This is a brief section. We're going to look at geometric mean. And the geometric mean is simply two positive numbers, A and B, and a positive number such that we have A over X is equal to X over B. And I'll show you an example of when you use that. If you solve this proportion for X, if we're looking to solve X, and X happens to be the same in both the denominator of the first proportion, and X also happens to be the same value as the numerator in the second proportion. If we're looking to solve for X, it's simply X equals the square root of A times B, which will be a positive number. So, alright, when would that be used? For example, if I have here, I'm looking at a blueprint for a home, okay, and on a sheet of paper it might be 5 by X, and on the large will be X by 45. So on this particular case, how will we write this? First of all, you decide how do you want to do this. First things first, I will do, this is the short side, so the short over the longer side, and if that's the ratio I want to use, it needs to be consistent for the section 1 or the blueprint 1 and then the real life 2. So if that is small over large, I have to do small over large for the small one, and then I have to do small over the large for the second diagram. What does that look like? We put the values in. Small over large is simply going to be, what's the small value or the short side is 5 over the long side, which is X. Same thing here. I have to do the short side again on the larger one, because this is the second one. The short side is what? In this particular case, it happens to be X over the long side on the larger one, which is 45. Now, if we look at this, this is going to be a geometric mean. When I get short over the long, I can clearly see the X is in both. It is the denominator of the small diagram, and it is the numerator for the large diagram. And I can simply find X by what I gave you before. X is going to equal the square root of A times B. Well, what's A in this case? It's going to be X equals 5 times 45 and the square root of that. Well, 2 would be 90, 180, 180 and another 45. What is that? 225. I got 225. 5 times 45, I get 225. Take the square root of that. Square root of 225 is 15. So X will be 15 for both of these. So the long leg here is going to be 15. And that means that the short leg here will be 15 there. I'm going to scroll back down so that you can get that copy. And then I'm going to do a brief example here, another example. All right, let's try another example here. Let's just say we were asked to give the geometric mean for the following values. Let's go 4 and 9. How do we calculate the geometric value? Again, it's going to be 4 over, I like the variable P, it doesn't have to be X. That means that P has to be the numerator of the other proportion over 9. How do we do this again? P is going to be equal to the square root of 4 times 9. And P equals the square root of 36, which is 6. Now let me show you really quickly. If you were just doing, if you know these are proportional, and you should because they say equal, you can easily see how you do it. Just cross multiply. P times P is going to be what? P squared equals the cross multiplication of the second one, 4 times 9. And 4 times 9 will be 36. P squared equals 36. What's the inverse of squaring the number? It's taking the square root. So to get P by itself, I'd have to take the square root of 36, which is still 6. So you'll get the answer even if you forget how to do this A times B, the square root of A times B. If you set it up as a proportional ratio and cross multiply, you'll get the same answer. P times P is P squared. 4 times 9 is 36. If I'm looking for P by itself, the inverse of squaring a number is simply taking the square root. And that's the geometric mean.